my wonderful students. I welcome you to Eko Learners Support for WAEC and NECO candidates. My name is Odusatolokwe Joseph. I am your instructor for today's class. I want you to sit back and let's enjoy this class together.
Eko Learners Support, a support program of the Lagos State Ministry of Basic and Secondary Education for WAEC and NECO candidates.
Good. Therefore, I hope you are ready. If you are ready to go, you might be wondering what we want to talk about today. But I know you know. Why? Just say so. You guys have done elements. Oh, sorry. You students have done element before. And there's one of the words, one element that is special. This element can be placed in group 1 or group 7. Do you know the element? Can you tell me? I can hear you saying hydrogen. Oh, that's wonderful. With that, let's dive into what we want to do today. Our behavioral objective, so essential to know the direction that we want to go. At the end of the lesson, student will want, you'll be able to list the sources of what? Hydrogen. Oh, good. Explain why we need hydrogen. And also explain the preparation of hydrogen and many other by the properties. So these are things that we want to achieve at the end of the class. Can we go on? Fine. Let's dive in. Now, hydrogen, as the name implied. So when you look at the picture, that is the H cross. Do you know that hydrogen take about what? 1% of the H cross. Very, very small. Okay, fine. But is it only where we can see hydrogen? No. You can equally see hydrogen in a combined form. For example, you all know water. Is it not? Let me pick my pen. Water. You have H2O. You discover that hydrogen is added to what? Oxygen to form water. Not only that, in acid, for example, hydrochloric acid, HCl. What do you notice? Hydrogen is being added to what? Chlorine to form what we call hydrochloric acid. Therefore, you can see hydrogen in a combined form. Let's move. Also, you need to note that as well, or let me pick my pen, that hydrogen too can be found in uncombined form. For example, in the atmosphere. But what? In a very small quantity. So you can find what? Hydrogen in the atmosphere. In a very small quantity. Therefore, how many sources do you have already? Are they saying 3? Good. The first one is H cross, about 1%. You can get it in a combined form, like water. Not only that, you can equally get it in uncombined form, like in the what? Atmosphere, as you can see in the picture. But this in a very small quantity. Good. Can we move on? Yes, we can. Let's move on. Hydrogen. Now, yes, it's getting more interesting. Hydrogen. Hydrogen. Do you know the symbol? Yes, I think you know. The symbol is what? H. You can have 1 and 1 here. Do you know that hydrogen too can exhibit what we call what? Isotopy, where you have the same atom or the same atomic number but different mass number. But in this particular case, we have it as a proton, 1, 1. Good. It's the first element in the periodic table. Fine. So if it is the first element in the periodic table, you will agree with me. How many electrons? How many protons? How many neutrons? Thus, yes, hydrogen have. Look at it. It has 1 proton, as you can see. Not only that, and 1 electron. I hope you know that, because for the proton is the what? Equal to the atomic number. And what's the atomic number? Atomic number is the numbers of protons that is present in the nucleus of an what? Atom of an element. So in this particular case, this is equal to the what? To the proton. For the electron, that's it that moves around the what? That move around the nucleus is called electron. And in this case, electron is equal to the numbers of protons, but different charges. That is why we said atoms are electrically what? Neutral. Meaning the proton should be +1 and the electron should be what? -1. In this case of what? Hydrogen. And +1 -1 will give you what? 0. That is why we said atom is electrically what? Neutral. Meaning the what? The numbers of electrons will cancel out the numbers of protons. Good. Let's move. Now in the periodic table, where will you place hydrogen? So wonderful. Look at where the hydrogen is. Placed in the middle. Meaning it can be in group 1 or group 7. So it can be in this group, or be in this group. But why is hydrogen sharing 2 groups in the periodic table? I will explain. Firstly, when you look at this here, hydrogen has 1 electron. It has what? 1 valence electron on that atom shell. And we can use that as well to determine the group which element could belong to. Because it has 1 valence electron, we say hydrogen should be placed in group 1. And also, when you look at this shell, it can take a maximum number of 2. Therefore, it needs 1 more electron to become what? Complete. And you can compare that with group 7 elements. Look at group 7 elements. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Yes, 7. Okay, 7, 8. Look at this particular electronic configuration as well. We discover that this atom shell needs what? 1 electron to become complete. Because after 2, you move to 8. And what is the valence electron on this? You have 1, 2, 3, 4, 5, 6, 7. So you can compare this with hydrogen that needs what? 1 valence electron also to get complete. Therefore, hydrogen can be placed in group 7 because it needs just 1 electron on the atom shell to get complete. And I can put it in group 1. Why? Because it has 1 valence electron. Please note this. It's very, very essential. That is what I have here. It's placed in group 1 because it has 1 what? Electrons in its valence shell. Good. It is placed in group 7 because it needs only 1 electron to become complete in that particular what? Shell. With that, we are good to go. Can we move to the next slide? Yes, we can. Let's move. Fine. How do we prepare hydrogen in the laboratory. How do we prepare hydrogen in the laboratory? So there are 3 ways in which hydrogen can be prepared in the laboratory. The first one is action of what? Dilute acid on the zinc. It's very, very important. Action of what? Dilute acid on the zinc. As you can see in the picture, when dilute acid is added to the zinc, do you know hydrogen is being produced? Not only that, action of cold water on what? Active metal, like sodium. This is very, very explosive, so you have to be more careful. Also, hydrogen can be produced in the lab, but you can equally produce what? Hydrogen by the action of what? Steam on iron. Yeah, these are the 3 ways in which hydrogen can be produced. The first one is action of what? Dilute acid on zinc. Good. The second one is what? Action of cold water with what we call on active metal, like what? Sodium. Then lastly, action of steam on iron. With this, hydrogen can be produced. So let's take them one by one. Action of what? Action of what do I call it? Dilute what? Acid on zinc. So dilute acid could be HCl or H2SO4. When it reacts with what? Zinc, it liberates hydrogen gas. As you can see here, you have hydrogen, and we have the zinc. Sorry about that. So we have the zinc. So when the what? Acid reacts with zinc, what happens? It produces the salt and what? Hydrogen gas. Also, you can decide to use H2SO4. You can decide to use H2SO4. So when this acid reacts with what? The zinc, granulated zinc, you need to increase the surface area to make the reaction faster. What happens? Hydrogen is produced. So the hydrogen that is given off is passed over a what? A gas jar. And you remember, if it is required dry, what happens? You need to use what we call a drying agent. So in this case, you can use a fused what? Calcium chloride or concentrated H2SO4 to dry the gas. And the gas is collected by what we call upward delivery or downward displacement of air. Why? Because it is lighter than air. And that is it. This is the solution. You have the HCl. So basically, you have dilute HCl with what? Zinc. Yes, solid. So what happens? There will be what? Splitting here. Cl minus and zinc 2 plus. So what happens? The zinc will go, the plus will go and meet the minus to form zinc chloride. Yes, then plus hydrogen gas. So what do you notice? You will have noticed that the zinc has gone to display what? Hydrogen. Why? Because the zinc is at the top in the what? Activity series, while the hydrogen is below. So those elements at the top can easily display those below them. And then the solution is passed over water. You know that? Because it's not extremely soluble water. And the collection, is pointing up. We call it upward delivery. Another name for upward delivery is called downward displacement of air. Note this. But if it is required dried, all you need to do is to get a drying agent. And the drying agent you can get here is either H2SO4, that is tetraoxosulfuric acid, or fused calcium chloride to dry the gas. And what we'll be doing, we just absorbed the water vapor. Good. Now, you need to note in this reaction why we don't use basically dilute HNO3 in the preparation of what? Hydrogen, when you are combining it with what? zinc? It's because HNO3 is a very strong oxidizing agent. You need to understand that. It's a very strong oxidizing agent. Oh, fine. If it is strong oxidizing agent, what will happen to the solution? When the hydrogen is produced, it will further oxidize to water. And with that, you will not be able to achieve what you want to achieve at the end of the what? At the end of the day. So you need to understand. So it will oxidize the hydrogen and form water. So it's very key to know that. It is only produced hydrogen gas with magnesium. So in this case, if you are using zinc granules, you don't use dilute HNO3. Why? Because the hydrogen gas that is going to produce will be oxidized. And the reaction is very simple. You know, I have HNO3, yes, then I have zinc. Good. So zinc will display this. So give, the 2 is going to give this H plus, this NO3 minus, this zinc 2 plus. So it's going to this, and to give then NO3, O2 plus, H2 gas. But what happened? Because it's a strong oxidizing agent, this will further oxidize into H2O. That is why it is not what? Advisable for us to use dilute HNO3 when we are preparing what? Hydrogen in the laboratory. Good. Okay, fine. Another way of producing hydrogen in the what? In the laboratory is action of what? Cold water on active metal. This is very, very essential because that active metal will be very, very explosive when dropped inside water. Therefore, in doing this, you need to be extraordinarily what? Careful. And we use cold water. We use cold water in the preparation of that. And what happened? Look at what happened. So this active metal, sodium, is passed over what? Water. What it gives? It gives sodium hydroxide with an alkaline and what? Hydrogen gas. But you need to remember that this reaction is very, very what? Explosive. So we say it reacts vigorously with cold water to liberate hydrogen gas. But if you have to reduce the reactivities of this reaction, instead of using a very reactive metal, you can decide to use calcium. Calcium will still give you the answer. Yeah. But in this particular case, at a what? A slower rate. So it's fine. What you want to achieve, you still get it done. Therefore, this reaction is another way. So when you look at this is the hydrogen gas that is being produced. And what happened? So this is the sodium that is being wrapped here with a piece of wire gauge, as you could see here, and this drop inside the water. So when drop inside the cold water, something happened. What happened is hydrogen gas is being produced. Hydrogen gas is being produced. This is another way of producing what? Hydrogen from what? Active metal on cold water. Fine. Yes, this is another way of producing what? Hydrogen. You know, I told you there are 3 ways to produce hydrogen from the laboratory. You remember the first one? The action of what? Dilute acid on zinc. You remember the second one? Do you remember the second one? Yes. Reaction of what? Active metal on cold water. Then this is the third one. Action of steam on iron. You remember this process requires what? A red hot what? Iron. So iron needs to be what? Heated. Iron needs to be what? Heated to red hot. before passing through what? Steam. So if it happens, look at what happened. Red hot iron pass through what? Steam. What do you have? You have this what? Iron. Iron what? Iron 3 dioxide. Or we call it tri-iron tetraoxide. Or you call it a black residue. So this is called tri. Tri means 3. Iron. Tetra what? Tetra means 4. Tri means what? 3. So tri-iron tetraoxide with the production of what? Hydrogen gas. It's very, very, very possible. But when you look at this reaction, look at the reaction. This is what? A glass tube, and this water. So what the essence of this is to generate steam, because you need what? Steam. So good goes to the what? Iron filing. So what happened to the iron filing? Iron filing is being heated in the combustion what? Tube until it becomes what? Red hot. So when the red hot come in contact with what? Steam that is being produced, what happens? Hydrogen gas will be what? Formed. And this reaction is by upward delivery, because it's pointing what? Up. Upward delivery, or downward displacement by air. So this is what is formed. This is another way of producing what we call hydrogen in the laboratory. Now the question for the day, these activities, we are going to do it together. Now what this activity is talking about, now I'm giving you 2 seconds to think about this and tell me the answer. Oh, good. So let's answer it together. In the preparation of what? Oxygen by heating what? KClO3. Oh, sorry. Let me pick my pen. Okay, by heating potassium triazo what? Chlorate what? 5. In the presence of what? A catalyst called manganese 4 oxide. What is being only moderate heat is needed because the catalyst acts by what? So they are telling us what is the work of this particular catalyst in the preparation of what? This reaction. I hope you still remember. Okay, so this is solid, so I need to heat. So when I heat, I need NO2, so this gives KCl plus 3O2 gas. Okay, fine. So if you put 2 here, then I put 2 here. So potassium is balanced, chlorine is balanced, and the oxygen is what? Balanced. So they are asking, what is the work of this? You remember the work of what? Manganese what? 4 oxide is to catalyze the reaction. That is, lower the what? Activation energy by making the reaction to react faster. So let's look at it. Lowering the pressure of the reaction. There's no pressure here. This is a gas. Increasing the surface area of the reaction. Is it increasing really? The surface area? No. So what do you think should be the answer? Lowering the energy barrier of the reaction. Do you think so? Or increasing the rate of what? Reaction. Yes, it increased the rate of what? Of this reaction. Therefore, making the reaction to react faster. Is that clear? Okay, if that is good. Did you get it? Fine. If that is the case, let's see what we have in the next slide. Okay, in this next slide, just simply saying, well done so far. We've what? Gone through an interesting part before getting to this.
Eko Learners Support, a support program of the Lagos State Ministry of Basic and Secondary Education for WAEC and NECO candidates.
So at this point, I want to say, in case you have a question or you have a comment, you have answer, yes, you can contact us through the words link displayed on the screen. Bye for now and see you in the next class.
Acing your WAEC and NECO examinations has been made easy by the Lagos State Ministry of Basic and Secondary Education with the Eko Learners Support for WAEC and NECO Candidates television program. Join seasoned teachers as they take you through these core subjects: mathematics, English language, physics, chemistry, and biology, targeting the exact syllabus of WAEC and NECO. Watch Eko Learners Support for WAEC and NECO candidates on this station. Learners can also connect with Eko Learners Support for WAEC and NECO candidates through these social media platforms to access more educational content and give their feedback. Eko Learners Support for WAEC and NECO candidates. Pass your examinations with flying colors.